So we already covered how to represent design and knowledge, and then using them for controlling or reasoning, right? Reasoning. Chapter 3 and 4 was the core element. Now the textbook is moving toward to how to use them. This chapter will cover how to interpret design knowledge within knowledge base. So chapter 5, and is made of 6 sections, and I will cover up to section 4. So role of interpretation, what is interpretation, and what is the issues in interpretation, and what can be the evaluation then. Looks similar to interpretation and evaluation. And then it goes into the spatial design description, because this one is coming from architecture department. The authors of the textbook is coming from architectural design. So they use many spatial design problems. Okay. So role of interpretation in language. Interpretation is key in language. Right? When I am saying a sentence using Korean language, you should interpret my sentence. When somebody is talking about Russian language, then also you need special rules and knowledge for interpretation. And in logic is a branch of mathematics. And interpretation is also handled in that mathematical logic. And finally, we'll cover what is interpretation in design. And in language, words in language constitute made of symbols. Symbols. Symbols like R, E, F, or these symbols of Korean languages. And words is constitute of symbols. And also signs, graphical signs, that refer to things. Something like ideas or objects. Symbols. What are symbols? This is a kind of symbol, or maybe this kind of symbols, looks like right? Symbols here. Symbols, you can say this is a symbol. And signs and symbols. Right? Signs, and so that sign refers to this object. Right? This object. And the hearer of language, listening is involved in interpretation. And then the hearer, the listener, should establish referencing from the incoming signs, incoming sound, incoming sentence. And then you find out some referring object, as a sign referring to some object. By interpreting the incoming sound stream, you usually finding out some or referencing. The speaker's meaning, speaker and listener and speaker, there's a language coming together, correspondence between what the speaker makes and then reference and what the signs suggest. And that was speaker and a hearer or listener as correspondence is coming together. That is a communication. Right? So here is the symbol of Parthenon. And there is a real object, and it is represented by this symbol or word or sound. And then when this word is coming to my ear as a listener, you usually referencing, remembering the object, which coming together with, so we call this one as a semiotic triangle, and probably proposed by that person 100 years ago. And in mathematical logic, so symbolic logic for interpretation. So signs. This one is also signs, string of signs, right? Symbols or signs, or the graphical signs, or sound, image that gives you a sign are decoded by listener or by watcher, right? Decoded, parsed, or interpreted to give meaning. So we call this as a deductive inference, not abductive, not inductive, right? Deductive. So deduction is similar to interpretation. Interpretation is trying to derive a new set of facts, or we can say implicit fact, implicit performance from a given set of facts, design description. Say this is an example. So when I show you this one as a design description, a given set of facts, you interpret or derive its performance by whether this one will or break or not, or how much weight it can be, how much it costs it can be. That is, we're trying to derive a new set of information from this given information. That is interpretation. But in real time, complex engineering design system, the interpretation of performance estimation is very complicated work. When I design a new car, then how can you predict the performance of the car in terms of cost, weight, or acceleration, something, within 10 seconds? And hydrodynamic performance, and structural performance, dynamic performance, or vibration, noise, all kinds of performance can be derived from a new car design. So that is our life of engineering, especially mechanical engineering. Interpretation in design, that is our final work to do with the knowledge-based system. The interpretation of design is similar to the problem of interpreting an utterance in natural language. So there are the similarities. We already see this one several times. Interpretation of language sentence is very similar to interpretation of design description. So design description can be any form, right? It can be a drawing, it can be a statement, it can be a specification book, it can be a photo, it can be a video. Interpretive knowledge, combining this interpretive knowledge to the design description, we can provide the derivation of the meaning of the design, or performance of the design. This is an image coming from design thinking. Design thinking is popular nowadays. And what can be the interpretation? And they are showing, what is this? Anyway, we see many times divergence and convergence in one axis, and synthesis and analysis is coming in another axis. This looks like a very general view design. Okay. So by divergence stage, can you remember that analysis, the iterative or procedural model of design, analysis, and then synthesis, okay, and then evaluation. Cycle is looping. And when I say synthesis cycle, you generate alternative designs. Then we can give you this is as a divergence stage. And then by evaluating and selecting one optimal one, you arrive at into convergence. Converge. So that you may match in this slide with the procedural model of design. Procedural model of design. We covered already this one. Right? I just remember. So divergence and convergence. Divergence and convergence, and synthesis and analysis. Analysis. It's related with each other. This one is very similar, analysis and evaluation, but specifically they are saying market analysis here. Market analysis. Here they analyze design alternatives, evaluate design alternatives. But deductive process is very similar here, but the target object is different. Interpretation is same interpretation. Deductive knowledge is used. Question? 저 카메라가 나를 안 쫓아오는 것 같은데? 자동으로 도는 게 아니었어 원래? 일부러 그렇게 놓은 거야? 스태틱으로. Issues in design interpretation. Syntax and semantics in design or in language. And role of parsing in design. Also, you can think about the language sentence of parsing. And incomplete knowledge in design interpretation. Always we should work with incomplete knowledge. Or incomplete description also, complete description. So that is problems, obstacles we are facing as engineering designers. And also similarly to inconsistency, ambiguity, and uncertainties are also involved in all over the world. In terms of data, in terms of knowledge, in terms of description, or includes this incompleteness, inconsistency, ambiguity, and interpreting design by deductive interference. That is already covered. We say several times. Interpretation is done, executed by using deduction, deductive inferencing. Now, syntax and semantics in design. So description itself can be seen as a syntax. They show some includes rules, grammatical rules in there. And then interpretation means we're trying to find out the meaning of that sentence. But many times the semantics and syntaxes are intermixed together. At one stage of interpretation or description, one level, it can be a semantics or it can be a syntaxis another at the same time. So we'll see that. And design is usually trying to find out the mapping between a space of interpretation and the space of design descriptions. So interpretation means performance, right? Performance. We already see in optimal design that space of performances, space of alternatives, or you say descriptions, alternative designs, design space, right? So mapping between. So this is something like a required performance or design requirement, and trying to find out the best design alternative. Or another way, interpretation goes in these directions. Or designing is so it can be analysis, it can be synthesis, or it can be a deduction, and it can be abduction. So given one design, then we can interpret the performance of this design. That is in this way, interpretation or analysis. But when I start from required performance, I want to design a best-selling smartphone for young Indian ladies. That is my wish and or requirement given to you. Then you should find out some design which hopefully can be a best-selling smartphone. So we call this is a synthesis cycle or abduction cycle. So design is trying to find the mapping between two spaces. One space for interpretation, meanings, semantics space, and space of descriptions or syntactic space. And this is a levels, they are saying levels. Where we can start. This can be more, I don't know which one is general or specific, but this, I cannot see any hierarchical levels. Anyway, so depending on dimension, the size of the knife, and which material it is made of, it gives you you can estimate the weight of this. Estimate or predict of the weight of this knife, but depending on the weight, gives you some. At the same time, it gives you the weight itself can be meaning to, or material gives you a semantics of this. The sharpness, how sharp is it, and also that gives you the how well this sharpness gives you a cutting performance in the sense. So at the same time, the sharpness can be semantics coming from weight, and it can work as a syntax for the semantics. So the shape or thickness of that sharpness, the value, can give you the performance of the cutting behavior, performance of it. So they are trying to show you some example of how, depending on the level, at one level, what the meaning of performance at one level can be used as syntax at another level. Okay, and then role of parsing in design interpretation. Parsing is trying to separate out the components into pieces and then try to interpret each one of them. So to interpret a statement or sentence, its structure or grammar should be understood. What can be the known, what can be the decorative one, what can be so should we understand that, right? So, or you have a programming, you also have a programming, the parser for the language parsing, the parser should check with first time the syntactically check it, whether this is correct in terms of language syntax. So parsing is a means of decomposing a design or sentence into component parts and check one by one whether this is correct in terms of syntax or grammatical rule. That is the first step. And then all the check is passed, is correct. Then we go on to the second stage of trying to finding the meaning of that sentence. And then the program can be used for working for action, execution. And incomplete knowledge in design interpretation. Incompleteness comes everywhere. Single sentence does not generally contain all the information for the interpretation requirement. There is a context that is not stated explicitly. The smartphone for Indian ladies. I say only simply one sentence. But you should see the context, the market in India. Also, I understand that India itself is a very big nation, right? So southern part and northern part, or city-wise or country-wise, the requirement can be different. Or also language layers, age layers, and also there are differences coming together. So we see this is context, environmental, surrounding factors, also important. Also design is too. So for example, they are saying thermal performance of a gearbox in a car or in an airplane, in a bicycle. The heat dissipation of the surrounding element is also important for that performance. It is covered well to protect dissipation, or there is a very conductive material is connected to that gearbox. It's different, gives you different performance. So context is important. Any uncertainty about context, but the context is not a very clear statement anyway. So that includes many uncertainties in which the artifact means the design, the smartphone itself in this way, smartphone is to be placed has a bearing on the interpretation process. So smartphone in India and northern part or southern part, or not in India. It can be China, right? It can be Pakistan. That gives you different context, right? And there is also an uncertainty. So while we are interpreting the performance of that, so I have a design, new design myself, right? Whether this one can be good for Indian ladies, can be different to China people, right? Or France. So that gives you different interpretation process. So we should use that kind of information together. And the context is also important. So uncertainty can be, we are saying, ambiguity, incompleteness, and inconsistency in this textbook. And there are more. Vagueness and randomness. But in this chart, they are saying these are all a subtype of uncertainty types. And many people are trying to find out, categorize uncertainty in this way. Inconsistency, ambiguity, and uncertainty. So very, I tried to translate into Koreans, but still they are not clearly separated out, very related each other, right? But different, but similar. Two people may look at the same design description and arrive at two different interpretations. Whether this one can collapse or not collapse. But there is one single answer, correct answer, but we don't know. But every people can have a different interpretation on this. But this one is very clear, simple problem. When you see a, say, complex description, right, or language statement, then interpretation can be many different variations. Right? So design description of, say, smartphone too. Right? Smartphone is very looks complicated one. Whether this one can be well sold in India, how do you think about this? Depending on your interpretation, you have a different opinion on this. Because that is coming from, the difference is coming from ambiguities in the way the design is described, description, and also in differences in knowledge bases. You have a knowledge base for your interpretation. You interpret yourself, right? You're using your knowledge base in your mind. So that knowledge bases are different from people to another people, right? And also the knowledge includes ambiguity, and also description also has ambiguity, so that the interpretation result can be different. Great. And deductive inference, we also see deduction here. Where is it? Deductive interpretation. Deductive interpretation, I already see this. And hierarchy of meanings, in that certain meanings can be deduced from another. There can be a hierarchies, trees of meaning, right? Trees of meaning, hierarchies of meaning. And in knowledge-based system, we are interested in making this hierarchy explicit in the way knowledge is organized. So knowledge-based can be also organized as hierarchical structures. So representation, interpretive knowledge as rules. Rule is very simple way of representing knowledge. One of the simplest form of interpretation, knowledge, is rule. So we call this knowledge base, or can be sometimes many people are saying rule base. And that is, rule is usually made of if and then and precondition and consequent implies. A symbolic representations. And section 3, the evaluation, design evaluation. And there are, if one design is given, some part is explicitly shown to you. There is something like structure type, number of span, type of support, and material used, and topology and geometry is given. Usually inside drawings, design drawings. But there are also implicit attributes is not shown in the drawing. So usually it can be a performance of that design. So you should have tools to interpret or predict their performances. Something like stability, traffic carrying capacity, impact on the environment, and aesthetic qualities. One example coming from this textbook is bridge, like this one. So structural type, number of span, type of support, materials, topology, and geometry is given on the drawing. But you should find out the performance of that, or you predict performance of this bridge or the drawing, stability, traffic capacity, environmental impact, and aesthetic qualities. what is this? So representation represent evaluative knowledge. Evaluative knowledge is similar to deductive knowledge in terms of algorithmic functions or rules. Rule is here. So knowledge is usually simply represented as a rule, or sometimes algorithms are also used. Right? So rules or heuristic evaluation. Okay. Section 4 comes to the spatial design description. Drawing, simply. So interpretation of graphical description inside drawing. And usually we are talking about geometry and topology in drawing, and geometry, shapes in engineering designs, and spatial properties. So we need to have a graphical knowledge is used for the interpretation or representation. So once again, the topology is different from geometry until they break into pieces. Topologies are same. I said topology is a neighboring information. Which one is next to you? Next to left neighbor, right neighbor, and below neighbor, above neighbor. The information is still same, right? The neighboring information is still same, even though the angle and distance is changing. Right? So graphical interpretation of geometrical description. Images can be drawn by means of deductive reasoning. So draw a rectangle by using simple movement of draw a line, move and move. So object can be drawn hierarchically by a set of logic statements. So the house can be drawn in this way, in hierarchical and set of logic statements. All of this simple, like this one. So hierarchy of this office or house is made of column and wall is made of line and point also. Column is also made of line and point. So and very simple graphics is made of hierarchical and simple components. And this is geometry, half planes, a polygon defining in terms of half planes and boundary segment. So this line, the equation of this line is something like this one. And if you say greater than, then you divide this plane or space into two parts. One is above or less and bigger or smaller. Right? So division can be done. And also using these lines, you can define this region. Right? Bigger, smaller, above or downward, you can define this space. Okay? So polygons can be defined in this way. And deriving spatial properties. The size, area, or inside, outside, containing, or that kind of properties can be geometrically defined. So geometrical information can be represented in predicate calculus notation. Where's predicate calculus? This one is maybe it can be a predicate calculus notation. So room and north and south, the edges, simple room. This is simple room. It can be defined as in this way, and then more complicated one is defined in this way. So architectural design, they want to handling, operating or controlling, manipulating these simple geometrical elements. And we are saying semantic network. Semantic network is just made of node and link. And looks like each node representing a room space. So each room has a linkage. So combining all together, we say this is a semantic network, describing the connection in a flat house. And also they are trying to use this semantic network for representing passes through planning joining room A to I. So room A is here, room I is here. So there can be a pass through in this way or pass through in this way, or the other way. So that kind of thing can be a geometrical manipulation, and can be used in this. No. Then we can go on to Benjamin.